Hello everybody, today we're going to be going over the Onshape Assemblies Learning Course. So I'm going to be going through the exercises for you guys. Yeah. Alright, so we'll start with the basic assembly exercise. So you can copy the document, I already have it copied of course, but you should be looking at something similar to this, and so we'll get right into it. So first you're going to want to create an assembly, pretty standard, bottom left hand corner, create an assembly, and then they want you to name it the hydraulic clamp assembly, hydraulic clamp assembly. Okay, cool. Alright, and so now we got to insert our assembly. This document has a bunch of part series in it, but yours will only have one. So there's two ways to insert parts. You can open the drop down and click and choose parts individually. Or you can click up here on the part studio itself to insert the entire part studio all at once, which is a little bit easier probably. Now, let me do that again just because I'm running into a bug. Okay, yep. So now you can see I can move my mouse around and place, you can see it follows my cursor, so I can place it in kind of in an arbitrary position out in space, right? You can also see when I mouse over the menu, it snaps to a default position. And so what that position is it's putting the origin here, right, in the same spot in the assembly as it is in the part studio. And so that's usually good. That's usually what we want because you should be designing your parts relative to the origin. So then it makes sense for the origin to be in the same spot in the assembly. And so the way you capture that behavior is you just use this green check mark instead of like placing it arbitrarily, right? So when I use this green check mark, you can see now it's in the default position. And I just want to be careful not to move it until I'm good and ready because this is free floating at this point. So next they have us fix a part. So that's a pretty standard assembly workflow. You always want to have one part fixed. That just locks it in place relative to the origin. So it kind of serves as the ground or like the source of truth for your assembly. And another way, and an alternative to fixing is you could just fasten a part to the origin. That is equivalent. And so the only thing with fixing is you just want to be very careful. You only ever want to fix one and only one part per assembly. Because if you fix multiple, it might work for the time being. But once you get into later assemblies, things can start breaking down because it won't respect the fixes, multiple fixes, when you start fastening it. Okay, so now we got to copy our O-ring, so we can do that by clicking it, Control-C, Control-V. And then we're going to go ahead and fasten mate it using M. So this is going to be fasten mate. Oh wait, sorry, oops, got ahead of myself. First they want us to mate the plunger to the swing arm, right? So you can see this is solid because I fixed it, right? But everything else is free floating, which is fine. So now we're going to go ahead and mate this, right? So now you may try to grab like a mate connector in the middle, right? But you can see I'm having trouble grabbing it, even though I can like see the mate connectors. And the reason for that is because I'm not locking to the face. So the solution is if I hover over this face and I press and hold shift, right? That will lock my selection to this face that I had hovered when I pressed shift. And so that makes it a lot easier to grab any particular mate connector on that face. Oops. So I'm going to mouse over this face, press and hold shift, right? And now I can grab this mate connector in the middle very easily. And I want to be careful to grab this one, not this one. This one is black and white. You can see it has the extra black. And that means it's the center of mass. So it's actually the center of the bounding box of this face, which is not what I want. I want this one, which is from this circle here. It's the center of that circle. So I'll do that. And then grabbing the top of the swing arm should be pretty straightforward. I can just grab it like that, right? And then let's say I were to click something wrong, right? I can see my selections up here. So if I, for example, messed up while grabbing my plunger face, right? I could delete it from here, right? And then I could go and grab my plunger again. Yeah, so that's good. So we'll go ahead and confirm that. And now we'll do our O-rings, right? And so one thing I'll point out is because this is in the same spot in the part studio as it is in the assembly, right? So you can see in the part studio is modeled correctly in the same spot. and so we don't actually need to move it, right? And so one alternative to fastening it in place is we could instead use we could fix it in place, right? But that would break the rule of fixing more than one part. So instead what we could do is we could use a group constraint, right? And all a group constraint does is it locks parts together wherever they happen to be in space. It just locks them in that position. And so if I were to group these two parts, because this is fixed, right, and this is in the right spot, then this is going to be constrained. And so that's a pretty common workflow when you have something from like a Part Studio. You can insert the Part Studio, fix one part, and then group constraint all the parts in the Part Studio, and then fasten from there. Anyway, okay, so now we'll fasten our other O-ring. So we'll go ahead and do that. And then once again, right, this is a lot easier to select if I do lock to this face first. So I'll mouse over the face, press and hold shift, right? And then you can see here I have the top, middle, and bottom mate connectors to choose from, right? You can see the correlation there. So I just want to be careful. Oops. Yeah, so I just want to be careful to get the middle one, right? Okay, so that looks good. All right, cool, moving right along. Yep, and then I already, I guess I won't use the group constraint here even though I could, just to demonstrate. So I'll do this one as well, right? So click it, pretty easy, and then once again lock to face, and then I can grab the middle one. And one thing I'll point out is there's this bar here and there's this bar here. So, you know, this just has the same options as these. So I can, you know, these are the same button. But one thing I will point out is if you use this group green check mark, it will just finish your fasten and take you back to the assembly like normal. If you use this one, it will finish it and then it will create a new mate automatically. That's the only difference. So, you know, sometimes you want to do fasten, you can use that one to save a little time. Okay, so now we're going to go ahead and create our cylindrical mate. And they want us to go ahead and make a section view. So the way you can do that is you can go up here, click section view, and then you can choose kind of any reference. You could choose this face. I'll choose this. And then I can spin it around like this, right? And I don't want it to hide my plunger. I want to be able to see those, so I can change my selection to items exclude, and I can select this guy and the plunger, so that way my section view doesn't hide them. But yeah. Okay, so I'll go ahead and confirm the section view. And if I wanted to turn it off, it's the same place I turned it on from, right? I could turn it off there, but I like it on for now, of course. And so now I'll start my cylindrical mate. And then I want to grab the bottom of this face here, right? And then I want to grab this face here. So pretty straightforward, right? And then of course this just gives me this free motion. Oh, and one thing I will point out, right? So when I fasten that, you can see this plunger has become disconnected, even though we just mated it, right? And so you might be a little confused by that. Not to worry. Sometimes when you fasten things, for performance reasons, Onshape won't update all the mates immediately. So if you do want to update the mates, the easiest thing you can do is you can simply confirm your constraint, and then it will update, right? So you can see it respects that mate that we added again, right? But you can also use the solve button, right? And that does the same thing, but obviously leaves you in the mate. So, you know, if it ever looks like it's become disconnected, or, you know, it's not connected properly, odds are good you can just click the green check mark and it'll fix itself, or you can click the solve button. Same thing. Okay, so now we'll turn on our limits. And so here we need a limit of -40 and 0, right? And so you can see that gives us the motion we want, which is good. Okay, cool. Now one comment I will make about the self-check is there is a bug. Basically the part they did the self-check on doesn't have these two fillets here. And so what that causes is it causes the mass properties to actually be wrong. So if I measure this, it's 12.043. You'll notice that's not actually an answer, right? So the correct answer here is actually 11.980, just because they have those fillets, or they do not have those fillets and we do. That's just a problem between the starter document and the final document, so it's not a big deal. You know, don't worry about it if you get what I got, or maybe if they fix it, then you might not have this problem, and then you know you can just disregard that. Okay. Anyway, moving right along, we'll now move on to the creating make connectors assembly. I named this wrong, but that's fine. Okay, so we'll copy the part studio. And then we want to go ahead and create a new assembly, right? We'll name it our toggle clamp assembly, right? Okay, and now we'll go ahead and find our part studio. Oops, I renamed it. Yours is named part studio probably. I renamed mine just because this is a document. But yeah, so once again, you can see I can click the part studio or open the dropdown and insert individual parts. Here we need all the parts, so we can just do that. And then once again, I'll be careful to use the green check mark so that way it's placed in its default position, right? Oh, okay, and then actually I wasn't supposed to do that yet, so I'll go ahead and reinsert. Because they want us to, wait, oh, never mind. Okay, so I'm supposed to grab it like this, right? Or I guess grab the base. Yeah, so if I click here, I get this manipulator. And then I can reorient it by, oh, okay. Sure, so I can right click this face. Right click the arrow pointing normal to the selected face, okay. Oh, okay, so I right click this arrow here and then I can select anti-align with Z. That's not what I want. We'll click align with Z, okay. And so now it's facing up. And then now we can grab this make connector here and click move to origin. And so that gets us more or less to the origin. So that's about the right spot. So I guess we'll call that good. I guess it's facing the wrong way, so I'll grab this arrow and flip it around 180 degrees. So we'll do that, and then I'll go ahead and fix it. Okay, sure. That seems about right. A little helter-skelter, but not the end of the world. Okay. So now we'll go ahead and fasten this. So we want this inner edge here, I think. So you could do like this edge or this edge, should all be the same, or this face. I'll do this face. And then they want this side here. And then it's facing the wrong way. So the way I can fix that is I can use my flip primary axis. So you can see I can flip this, and then this rotates at 90 degrees each time you click it. So this is symmetric, so it doesn't do anything. But flipping and rotating are how you can control the orientation at a high level. Okay, cool. So now we'll grab, so we'll grab a slider mate, and then they just grab the middle of this barrel, right, which works. And then we want centered at the hole. Okay, I think that's this mate connector here that they have. And again, if it was facing the wrong way, I could use the flip to flip it around. I think it's a little bit arbitrary. Yeah, because the slider mate just allows it to rotate. Oh, and then I guess you do have to be careful to make sure this is facing the right way. And so the way you can fix that is by using, you can see this now, you can see what it does, it rotates at 90 degrees. Yeah. Okay. Yeah. So moving right along, right? So we want to mate here. We need to add an explicit mate connector because there's no implicit mate in between this these two gaps. So the way we can do that is we create our mate connector. We choose here, we change this to between entities, and then our between entity will select this face and this face. Nope, we don't need to do that. We can just select this face, yep. So you can see we start here, and then we say between this face, so it gives us the middle, which is perfect. Okay, and we'll go ahead and confirm that. Okay, and now we want to go ahead and fasten this using a revolute mate. So I'll grab my mate connector that I added, and then I'll grab the middle of this face. And so if I confirm that, you can see we can rotate now, and then this can slide in and out. So that's good. And I want to make sure this is facing the right way. So if it wasn't, I could flip it around. This looks good. Actually, is this right? Oh, it's wrong. Oh yeah. Wait, is it right? Yes, this is right. Oh, nope. I do actually need to flip it. Okay, yep. So I can do it like this, and I can click and drag, and you can see that's... Oh, it's actually... Okay, I did actually have it right. That's funny. Okay, cool. All right, and now we got this linkage arm. Is this linkage arm symmetric? I believe it is. That's convenient. Okay, so we'll grab here. Here, it might be helpful to lock to this face using shift again, right? I can grab the middle mate connector then, and then here I'll also grab the middle mate connector. And I want to make sure this arm is facing the right way, so I'll flip that around, and then I can, not quite. Okay, I have to be in the main assembly. Oh, it's not letting me drag because it can use the slider mate. Sometimes dragging assemblies can be a little bit janky. It's a little unfortunate, actually. I think I'll grab this and try to rotate it. Nope. Oh, I used fasten mate, that's why. Fun fact about mates, actually, they're actually interchangeable using this dropdown. So I don't actually have to delete my fasten and change it to a revolute. I can just change it to a revolute like this. And then, yeah, now I can rotate it. Yeah, and dragging can be a little janky sometimes, but you can always like click like I did and like use the explicit try manipulator to only move one thing at a time, or you know, like sometimes if you like come to like an explicit side view, then it's a little bit more defined, because when you're in 3D, you know, it's not so clear exactly where your mouse is. But if you're like facing it from the side, then you know it's a little bit more clear, this system and this rotation. Okay, cool. And then once again we'll revolute. This isn't actually normally what I would recommend, because you're actually adding, basically the problem here is we're relying on the fact that this revolute has the right offset, right? So this technically works, right? Here again, you can see it moves it out. So if I click the solve button, then you can see it finds a valid solution. But yeah, so here we're relying on the fact that this revolute, like this part is centered, so it's correct, right? Because a revolute constrains side to side and just not rotationally. And that's actually a little bit janky, because sometimes the Onshape solver can get confused by it, or it can get caught up by it. It can actually hurt performance, and actually can give you some really janky behaviors that you don't like. So in this case with a simple assembly, it's fine. But normally, if you don't explicitly need the side-to-side constraint, it's normally better to just use a cylindrical mate instead of a revolute, because then, you know, Onshape doesn't have a problem with like loops or things like that when solving. Because it doesn't have multiple mates telling it, you know, the side-to-side motion. So hopefully that makes sense, and you can kind of see why this revolute mate is a little bit, the side-to-side motion on this revolute is a little bit redundant, because of the way these parts are connected and the way this bracket, plus this part and this part already define this bracket. Okay, so now... Yeah, so we're gonna make a section view again on this guy here. I'll just click this face. I'll exclude these parts so I can see them. And then I'll set that. And then we're gonna go ahead and grab, oh actually, okay, I don't want to be all the way on this face because I need to get this face here, and if I'm like flush against it, then I don't have that face, I only have the edge, which is not helpful. So I'll grab that, and then I can grab my fasten mate, right? If I grab the face, you can see I have my start, middle, and end. I'll lock to the face, grab my middle, and then I can do the same thing up here, grab the middle, and here I need to rotate 90 degrees. Yep, and so that looks great. Okay, cool. And now if I turn my section view off, right, you can see this is right. Yeah. Okay, so we'll go ahead and move this all the way. Close the arm completely. Really? Okay. Well, my center, so my origin isn't quite on this corner, so I can fix that real quick. So I'll just unfix this. I'll actually grab the corner this time. I'll move this triad. I should be able to just, yeah, so I'll grab this corner here. I'll move the triad to the corner. Let's see here. It's a little janky. Oh boy. Okay. So I guess if I click this face, then I click this, right, and then I click and hold it, I can select a corner, but it's kind of buggy actually. So here I see, like if I move my mouse around, you can see it's kind of flickering. That's not great. But when it's like this, I guess I can press and hold shift to lock to this face, and now I can select it normally. So I'll go ahead and grab that there. Definitely a little bit buggy. That's normally you don't have to do this. Normally you just design. This is why it's better to design your part studio with the origin in the correct spot, so you don't have to like use this workflow, because you just insert in the default position and then fix it right away, and then it's right, and you don't have to worry about it anymore. Anyway, okay, cool. Yeah, this doesn't actually. Oh, was I supposed to add limits or something? Let me check. Revolute. Did I miss a step? Oh, I did miss a step. Okay. Yeah, that's my bad. So this revolute here is supposed to have limits. Minimum is 1.5 degrees. Maximum is 86.5. Right, if I click solve, you can see that. And I can also click this play button to play through the limits, kind of. But it only moves the part, doesn't solve the assembly. But yeah, so, oopsies, I forgot to fix. Oh no, okay. I'll fix this, I'll re-add my limits, that's sad. I had to undo there to get it back to the origin. That's fine, okay, cool. There we go. So a little helter-skelter, this is wrong. Oh, I have to rotate this correctly. So the limits are defined, yeah, I think vertically. No. Like this, maybe? That looks right. Okay, yeah, so here's my limits there. Okay, perfect. All right. Cool, so now I can close it all the way, and then I can grab my parts, and I can grab my center of mass, and I'll do the self-check. And then, oh, I'm not even rotated correctly. Ugh. That's annoying. Okay, let me just line up. Oh, okay, they want me to rotate 90 degrees. I'll unfix it again. Move this to the origin. And then I'll grab this guy here. Okay, I want it like this. 90 degrees. You don't, yeah. Okay, and then I'll fix it. I wouldn't, if I were doing this for real, I wouldn't worry about like, I wouldn't worry about this self-check, honestly. Like, as long as you have this motion and like this is correct, and like it's fixed, I wouldn't worry about where the origin is too much, because that's just not really a workflow we normally use. But anyway, I'll do it for posterity. So there we go, and now we can see this is right, so that matches up, and we passed it, so yay. All right, one more assembly, okay, perfect, yep. So I already did this exercise, so I don't actually have to copy the workspace, but you can if you haven't. I have it here, so that's convenient. I'll go ahead and make an assembly now. Name it small arm sub-assembly. Cool, don't need that part studio. Okay. Cool, yeah, so now we're gonna insert only part of our parts. So I'll open this, and they just want the pivot pin, the small arm grip, and the small arm pin. And once again, I'll be careful to use the green check mark instead of placing it arbitrarily in space so that my origin is in the right spot. Yeah, and so now we're going to use the group constraint because these parts are already in the right spot relative to each other. So I'll just go ahead and group those real fast. Very convenient. Right, and so now you can see these are constrained relative to each other, so you can see what the group constraint does. Okay, and then, what are we doing? Oh, okay. So they're having us move this to the origin. There's an easier way to do it, and that's to just design it so that this origin is in the right spot to begin with. I guess I won't do that now, but normally you would just like design this. So like instead of like modeling off of the right plane, for example, or I guess the front plane, you could just create an offset plane that's, you know, half the width of your clamp, and then sketch on that, and then the origin would be in the right spot automatically. You wouldn't have to do this workflow, but that's fine. So okay, pivot pin, yeah, okay, and then I'll click this, lock and hold, grab the middle, and now I can right click and click move to origin, and then I'll go ahead and fix this. Yeah. And I'll click fix. Okay. Yeah, so again, not normally a workflow. I've never actually done that before, like ever. But I guess you can do it if you really care. Okay, so now we're going to fasten this. I'm wondering why we're fastening this and not using, maybe, okay, yeah, so we'll just fasten that like normal. Should be an old-handed fastening by now, hopefully. Okay, and then we're gonna copy and paste this arm. Control-C, Control-V is probably the easiest way to do that. Once again, we'll fasten it. La-di-da, la-di-da, pretty standard stuff now. Okay. Cool. Okay, we're making a sub-assembly, interesting. Right, so we'll make another assembly now. And we'll name it our working clamp assembly. Okay, I will insert, okay, so now I have to go to the assembly tab explicitly. So this is my list of part studios, this is my list of assemblies. And then I'll grab my small arm assembly. And then once again, same thing. I can place it arbitrarily or use the green check mark to get in the default position. Okay, and then I have to fix one part again, just like any assembly, right? Every assembly should have one part and one part only fixed. So we'll do that here, fixing the pivot pin. Okay, and then we're going to insert our other parts. So we'll insert our large arm, large pin. Yep, and we'll confirm that. Right. And once again, because these are already in the right position, we can just go ahead and use a group constraint. Very nice. Okay. So here we can use a revolute mate. And was it actually supposed to be a fasten mate? They definitely show a fasten. Yeah, that's funny. They definitely show a fasten mate on the revolute. I'll go back and fix that because it's easy. So they show it using a fasten mate. It's supposed to be a revolute. That's why it's not just grouped, because if it was just grouped, if it was fastened, you could just use the group constraint and life would be easy. But yeah, I'll just change it to a revolute real fast. That's kind of funny. Okay. So, yep. Okay, hum-da-dum-da-dum. Yeah, we already did that. Okay, now we're gonna go ahead and fasten this to this. Right. And you might be wondering why we can't I guess I'll fasten like this. Yeah. You can also grab that interface. It's also perfectly fine. Oh, that's supposed to be revolute. Again, we'll change it. Nice and easy, not a problem. Okay, and because it has to be revolute, yeah. Okay, so that's fine. Okay, and then they want this in its own subassembly, so they're just showing the workflow where you create one inline. So I can do that. Click move to new subassembly. It inserts in my top level, so I just have to move into my folder. You shouldn't have to do that, but it's something to be mindful of. And then I will give it a name, large arm subassembly. Cool. Okay. Oh, yep. And then once again, right, any assembly, you should have one part only fixed, so we'll do that. And then we'll copy paste that and fasten it. So once again, using shift to lock to faces makes selecting a lot easier and faster. Okay, and then we need another large arm pin, so we'll do that. Control C, Control V, and then we'll fasten it. Very nice. Okay, and so now if we go back to our top level assembly, we can see we have a pretty nice clamp. Can you revolve, please? Aha, yep. So because we fixed the small arm pin, right, this small arm is static, and this is our relative motion. Yeah. So, and here our dragging behavior is a little bit better if we align normal. Sometimes it can be a little bit janky if you're looking at it from the side, although it's not too bad in this case. This assembly is pretty simple. But you can see, like, I can't like rotate this and move the arm at the same time, which is a little weird. But that happens sometimes. Okay. Now we're gonna edit this guy and add some limits. So here we can set a limit of 0 and 30. Right, if I click play, you can see that. Cool. Yeah, so now I have that motion limited. Okay. Oh, do I need to rotate? I think I need to rotate. No, that's what I had. Sometimes limits can get reversed. So I think here I actually need to be from -30 to 0. Just because like if the direction of the mate connectors gets reversed, then it happens. I wish there was a button to like flip it automatically, but there isn't. So you just have to do like the negative variant of it. Yeah, so that's closer to what we want. Okay, yep, so then we put it in this position, and then we grab this guy here, that face, and this bottom arm, and then we get our parallel axis distance, which is 256. And so we can do the self-check. Nope, that is wrong. Really? Oh, is it because... Okay, it's probably because they're using a non-resize version of this. So like at the end of the multi-part parsuiter, they have you like edit all the dimensions to resize it. And I guess the answer they're using in the self-check doesn't have that resize. So I'll go ahead and just, yeah, so the correct answer is supposed to be 151.673 millimeters. Obviously this looks correct, so I'm not going to worry about that. But yeah. Okay. Cool. So we'll call that good. Yeah. All right. Thank you very much for watching, and I hope this was helpful.